Alright, guys and gals, we're going to be examining trigonometric functions, finding exact values of expressions involving certain angles in terms of degrees or radians. This example is in radians with some operations upon it. So the first thing we look at here is we see that we have sine of pi over 4 and tangent of pi over 4. And we have to remember that these are operators upon these. They're not anything separate. So it's basically saying 2 times the sine of pi over 4, which should be one answer, and 3 times the tangent of pi over 4, which should be another. Find them, plug them in, and add them together. So the first thing we have to ask ourselves is, what is the tangent of pi over 4, and what is the sine of pi over 4? What is the tangent of pi over 4? So the first thing we have to check again is what is pi over 4. So if you're not sure, if you remember what that is, you can do a quick conversion with 180 equaling pi. Remember that if I want to get to degrees, I'm going to put it on top and pi on the bottom. Cancel out. I multiply through and I divide. This is going to give me 45 degrees. So if you remember with our unit circle, and you can check your unit circle while you're looking at this, but this is asking us, when is this theta, angle in standard position, going to be a positive 45 degrees rotating counterclockwise? Well, if you can see that we have 45 here, and this is 90 with the right triangle that we've made, then this has to be 45 as well, giving us a 45, 45, 90 triangle. And remember that the hypotenuse of every right triangle created in a unit circle is 1, so that's how we have this. And if we go back, we remember that the 45, 45, 90 formulas go x, x, x root 2. And if we check back in our notes, we can see that the other two sides that were given to us with x and x, we found them as this. The square root of 2 over 2. Those are the exact values by finding that, and that was simply by setting 1 equal to x root 2, getting 1 divided by the square root of 2 equals x, and then we had to multiply that by the radical conjugate of the square root of 2 over the square root of 2, giving us this, and both of these sides are positive because we will be in quadrant 1. So now I think we're ready to plug in by either using SOHCAHTOA or by just knowing that the sine is always the y coordinate and tangent is the y over x of that coordinate that's intersecting with the unit circle. So I have 2, and I'm going to put parentheses, plus 3 parentheses. Well, we can start with theta and say sine is opposite over hypotenuse, so I can say opposite over hypotenuse from theta, giving me square root of 2 over 2, or I can simply state that that is the y coordinate of this point according to my unit circle. And then the tangent of pi over 4 is going to be the opposite over adjacent. So really what I'm doing is I'm dividing something from itself, giving me 1. And that can be solved by taking both of these and dividing themselves, or just looking at the point and knowing that if anything's the same, it's going to divide to 1. So I just get to put 1 right there. And we're pretty much almost done here. I'm going to multiply through. I can see that I have a 2 here and I have a 2 here, so I can cancel those out, leaving me the square root of 2 plus 3. And if it wants the exact value, then this is as far as we are going to go, because the second I find some decimal, I'm going to end up rounding at some point, and that's not exact. So this is a way to find an exact value of operations with trigonometric functions.